Hi friends, welcome to my YouTube channel. Today we are going to discuss about ACI method of concrete mix design. So let us solve an example for that. Here we are given that we have to design a concrete mix using ACI method. The structure is exposed to severe atmospheric conditions. The 28 days cylindrical compressive strength is 28 Newton per mm square. The cement we have to use is OPC, that is ordinary Portland cement. The coarse aggregate available is graded from 5 to 80 mm. That is the maximum size of aggregate given is 80 mm. And we are also given with the dry rodded weight of the coarse aggregate, that is 1760 kg per meter cube, and finest modulus of fine aggregate is 2.8. Required slump is 25 to 50 mm. Specific gravity of the cement is 3.15. Specific gravity of coarse aggregate is 2.68. Specific gravity of fine aggregate is 2.64. Now let us see the solution part. So our first step is to determine the air content. Air content depending upon the atmospheric exposure conditions we will be determining. So this is required for only the air entrained concretes. Our concrete mix design is as per ACI 211 codebook. So from the table 10.17, using the water requirements for different slump values. See, in this table we are given various water requirements for non-entrained concrete and air entrained concrete. So for air entrained concrete we will be getting the air entrainment values and also the water content requirements. See, the water kg per meter cube of concrete for indicated maximum size of the aggregate. The above table is for the non-air entrained concrete and the below one is for air entrained concrete. So for air entrained concrete we will be calculating the total air content percentage. So we are given the maximum size of the aggregate. Our maximum size of aggregate is 80 mm. So for 80 mm we would be taking the air content, that is 3.5. So for our condition we are taking the air content as 3%, 3.5%. So we are done with the first step. Next step we have to determine the water cement ratio from strength considerations and durability considerations. For strength considerations we will be using the table 10.16. So depending upon the probable compressive strength we got at 28 days, we would be getting the water cement ratio. See, if the for the air entrained concrete we are seeing the values. So the nearer value we will see this. So depending upon these values we will be getting the water cement ratios. If the value is in between any two ranges, we will do the interpolation. I will also explain you that method. So here from 10.16 table I have got the water cement ratio from strength considerations. Our next step is to calculate the water cement ratio from durability considerations using table 10.15. This is the table 10.15 maximum permissible water content ratios for different exposure structures and degrees of exposure. Here the water cement ratio is given for different types of structures, also for the different exposure conditions. The types of structures are given in this side and the exposure conditions, whether it is severe or mild depending upon the temperature or exposure conditions, like the water conditions. In fresh water it is there, or in sea water, in air or fresh water or sea water. And we'll also divide it in this way depending upon the sections: moderate sections, exterior portions of heavy mass. So depending upon the concrete we are designing, if it is used in this condition we will be using this water cement ratio. So depending upon both the exposure conditions and the type of structure for which we are designing the concrete, we will take the water cement ratio. So in this I am taking severe exposure conditions as given in the question. See, we are given the structure is exposed to severe atmospheric conditions. Okay, severe atmospheric conditions. So severe atmospheric conditions I am taking it as 0.48. Okay, in air I am assuming it is in air, so I am doing this 0.48. If anything specifically is mentioned that it is exposed to fresh water or sea water, we will be taking this. So from table 10.15, depending upon from durability considerations or exposure conditions, I am getting the value of water cement ratio as 0.48. After getting the water cement ratio from strength and durability considerations, we will take the water cement ratio that is minimum, because that will satisfy both the considerations. Our next step is to evaluate the mixing content, like approximate mixing water. Okay, we will get this from the table 10.17, that is the same table we have used to get the air content. So using the same table we'll get the approximate mixing water. Back here, we are taking air entrained concrete, and also we are selecting 80 mm maximum size aggregate. So for 80 mm maximum size aggregate, we are taking this for 25 to 50 mm slump. Okay, we are given the slump as 25 to 50 mm slump. So for 80 mm we are taking 123 in kg per meter cube, they have mentioned. So the water to be added is 123 kg per meter cube of concrete. So the approximate mixing water for the slump is 123 kg per meter cube. Next, to get the weight of cement, what we will do is, see, to get the weight of cement, we will do weight of water by the water cement ratio. Weight of water by water cement ratio, we'll get the weight of cement. So once we get the weight of cement, we will now calculate the volume of coarse aggregate required. For that we will be using the table 10.18. See, this is the table. We will get the volume of dry rotted coarse aggregate per unit volume of concrete from the maximum size of aggregate. The maximum size of aggregate given for us is 80 mm. So we'll just interpolate in between these values. Okay, we are also given the fineness modulus of sand in between this. So it is 2.6. So we'll get these values. So 0.79, 0.85. So after interpolating, I am getting it as 0.8. 0.8, that is the volume of dry rotted coarse aggregate per unit volume of concrete is 0.8. So the weight of coarse aggregate is equals to the volume of dry rotted coarse aggregate per unit volume of concrete multiplied by the draw rotted. I will show you this. The 1760 we have been given in question, that is dry rotted weight of coarse aggregate. So if we multiply this volume of dry rotted coarse aggregate per unit volume of concrete with this dry rotted weight of this coarse aggregate, we will get this value, that is the weight of the coarse aggregate we will get. Okay, next we will be calculating the solid volumes of materials per centimeter, like centimeter cube. In centimeter cube we will be calculating. So we will be calculating the volumes of all the materials. Let's start with cement. So for calculating cement volume of the cement per centimeter cube, like in centimeter cube. So that is the weight of the cement. The weight of the cement we have got is 280 kgs. 280 kgs. So this 280 divided by 3.15, that is specific gravity of cement, multiplied the whole by 10 to the power of 3. Okay, so multiply 280 by 3.15 into 10 to the power of 3, that is we are converting all that to centimeter cube. Even same for water. The weight of the water required by specific gravity of water, that is 1 into 10 cube. Okay, for coarse aggregate also, the weight of the coarse aggregate by specific gravity into 10 cube. Okay, so the entrained air we are taking it as 3.5%. So 3.5% means 3.5 by 100 into 10 power 6. Okay, so that is 35 into 10 to the power of 3. All this is in centimeter cube. Okay, so to get the total volume except fine aggregate, we are all doing this to find out the volume of fine aggregate, from which we will be calculating the weight of the fine aggregate. Okay, so for this, first of all we will be adding all this, the cement one, water, coarse aggregate, entrained air. We will get this value. We know the concrete to be calculated for 1 meter cube, that is 10 to the power of 3 centimeter cube. Okay, so we are all converting it. See, this is centimeter cube. The 1000 minus 773.02, that is total volume of the concrete except fine aggregate. We are subtracting that, so we will get only the volume of fine aggregate. Okay, so here we are getting volume from weights. When we are getting volumes from weights, we are doing by specific gravity into 10 to the power of 3. But here when we are getting weight from volume, we will do into specific gravity, that is multiplied by specific gravity and divided by 10 to the power of 3, we'll get the weight of the fine aggregate. Okay, so all the batch quantities per meter cube of concrete are: cement is 280 kg per meter cube, water is 123 kg per meter cube, fine aggregate is 600 kg per meter cube, coarse aggregate is 1410 kg per meter cube. So this is the end of the concrete mix design using ACI method. We can also adjust the this concrete design as per the field adjustments, like field conditions given, like bulking of the fine aggregate or water absorption of the fine aggregate, moisture content in the fine aggregate. So depending upon that, we will be adjusting the final values we have got. That is it for this video. Thank you for watching my channel. Please turn the black thumb blue. Please like, share, comment the channel. Please subscribe to my channel. Thank you for watching the video. Thanks for watching the video. Please like, share, comment to my channel. Please subscribe to my channel.